All right, we're good to go.
Awesome. So it looks like we're just doing a review here this week, huh?
Yeah, I'm in the quiz already, and it's just review questions, so that's kind of nice.
How long is it?
The 12 question look like?
That's
Nope.
it?
Oh,
Wow.
no, I
No,
was
there's
wrong. 31.
Yeah, I was gonna say that sounds more like it. It's supposed to be like a mock exam. They're not the exact same questions, but from last week that if you do well basically on this mini quiz here, then you should do well on the exam. And he says people overall average about a B.
Okay.
So on the first exam.
Well, let's see how we can do then. I'm good to go on question 2 if you guys have it open.
I do have it open.
Okay, so question 2, which of the following variables is or are categorical? To me, it's the number 2 is correct. A randomly selected brand of toothpaste at a convenience store.
yeah, because the other ones are numerical ones, right?
Yep. Or quantitative, I think is the word.
Quantitative, yeah.
Yeah. Number 3.
Number words.
Oh, you can select multiple. Oh, I don't like those. Okay. Age. The only other one I might select is age in years of randomly selected vehicles, meaning the year being categorical, even though it's a year as a number. So I don't know about that.
Which question are you on?
Sorry, I went back to 2 because I just realized that you can select multiple.
Yeah.
So my only question is the age and years of randomly selected vehicle, is that categorical? I don't think it is. You still there? Any thoughts? I don't think it is. It might be, though. Could be wrong on that.
I can see how it go both ways.
Yeah.
I think it leans closer, though, to what the first answer is, like the number of animals in local zoo. I think it's closer related to that, though, than it is by a randomly selected brand of toothpaste. It may be randomly selected vehicle, but the age in years is what you're focusing on, and I think that's the difference, is where it becomes numerical. If it wouldn't have said age in years, if it would have said randomly selected vehicle, then I think it would have become categorical.
Yeah, I agree. I think I'd lean towards that one is quantitative as well, but
Right.
Yeah, I think I remember reading somewhere that it was number based. It was.
yeah.
I
We'll find out though, I guess. So
yeah.
let's move on. This one's a little tricky. Because I don't remember the exact definitions of these words, but the mean IQ test score in the United States is 100. 20 randomly selected statistics students who took an IQ test and the mean of their score was 112. Which of the following statements is true?
Yeah.
This one's multiple choice as well. Like you can select more than one answer.
I believe it's 100 is the parameter and 112 is its statistic.
Yeah, that's exactly what I was thinking.
That's what I would put. Any other thoughts on that? Or should we move on?
No, that's exactly what I was thinking too.
Okay. Rotham City has 4 distinct neighborhoods. The property values are very similar within each neighborhood, but they vary considerably from neighborhood to neighborhood. One neighborhood has very low property values and another has extremely high property values. Property taxes are usually roughly proportional. What type of samples should we collect to gauge? Okay, this is pretty simple. Let's see. Oh, I don't remember these terms very well.
No, I don't either.
Let's see.
I think I'm in the reading, and there's on number 2 you can click the show summaries,
Uh-huh.
and I think the year is enough to make it a categorical value variable
Oh, you're talking about number 2?
on number 2.
Oh, okay. Is enough to make it so you would click age in years?
Yeah, I think it because it says it represents a non-numerical data that can only be considered as a label. So I think it's where the age of the car, I mean, you can only have one age of a car. I think that would be the label for them.
Okay. I think that's probably right. I think that one would be categorical then.
Okay. So it says on number 3, it says a parameter is a true but usually unknown number that describes a population. A statistic is an estimate of a parameter obtained from a sample. So 112 is 100 is a parameter.
And that's what we got.
Yep.
And then we're just looking for number 4. We just need to know the definitions of these different types. Let's see where that would tell us. Oh, here they are. So here's the definitions of these. A simple random sample is a random selection taken from a population. A systematic sample is every nth item in the population beginning at a random starting point. So we wouldn't use systematic. A cluster sample is all items in one or more randomly selected clusters or blocks. We might use that. A stratified sample divides data into similar groups, and an SRS is taken from each group. I think it's stratified.
Yeah. Yeah, but of all the definitions, that sounds right.
Yeah, that would be the one I would pick, because we'd have to go to each neighborhood and take a simple random sample from each different type of neighborhood.
Okay. Sounds like we're going to get to pick one for each of these. So number 5 says, when designed experiments are conducted in a public school systems, researchers typically choose a particular district and randomly select teachers of, say, 4th grade students in that district. Is then conducted using all the students in the selected classes. Which type of sampling scheme is this?
I'm just
That sounded like a cluster, I think.
cluster is all items in one or more randomly selected clusters or blocks. Let's see, when designed experiments are conducted, researchers typically choose a particular district. Okay, so they're going to choose one district, randomly select teachers of one grade in that district.
And then they're going to select all of them. And that's exactly what a cluster is. It's all items in one or more randomly selected cluster.
Oh, okay. Yeah, so it would be a cluster. Sounds good. That's perfect. Okay. School fundraiser. The name of every person who attended was entered into a drawing. At the end of the evening, 6 names were selected to receive door prizes. Which type of sampling scheme was implemented? So
Would that be a random?
that would be a simple random sample, I believe.
Yeah, I think so too.
That's
Okay.
So a special interest group is conducting a survey regarding wolves in Yellowstone National Park to adequately gauge opinions on both sides of the political spectrum. The researchers registered Democrats and selected a simple random sample of 100 people. And they took a list of the registered Republicans and selected a simple random sample of 100 people. Which type of sampling scheme was implemented? That would be stratified.
Yep. Stratified.
So do you think stratified could be used for 2 answers? Because we also have that for 4.
I know. I was going to look at number 4 again. Yeah, I think number 4 is also stratified.
What's the definition of systematic?
Systematic is like every 10th. So a systematic would be every 10th house. You pick it. You know what I mean? That I still think that one would be stratified though.
Which one? Number 7?
No, number 4. We're
Yeah, I
questioning.
was thinking maybe 7 could be possibly systematic.
No, 7 wouldn't be systematic.
No? Okay.
No. I guess number 4 might be a systematic sample, but I don't I think a stratified sample would work better for number 4 still.
Yeah, I do too.
All right, well, we'll fix it if we need to, I guess. Okay. Open the Crossroads purchases. Is that what I opened? Yes. You guys have that Excel open?
I do.
I'm getting there. My Wi-Fi is horrible here.
Where are you at today?
West Texas. I'm in Midland.
Gotcha. I know Midland. I used to work in Odessa for a little bit.
I do. I'm
Yep.
actually in Big Springs, if you know the area. So.
A little bit. Yeah, I went down there for a while to help out our Lubbock branch, and they have some over-the-road routes that go down to Odessa every day.
Yeah. This lovely place.
Is there a way to calculate the mean on Excel?
There kind of is. So if you put equals, type in average,
Okay, that's what I thought. Average. And then
and
you
then click
select
the
all.
cell. Yeah, click the cell. Left parentheses, and then click the cell that you want. And
Okay. Setting up all question 8 is asking. Calculate the mean of the amount spent. So I got 4.771.
yep, that's what I got.
Number 8.
I concur.
Okay, and then it's going to ask standard deviation, which is STDEV.
Threes.
I got 1.912.
Two.
Yep, 2. Yep.
912. Or 1, sorry, what did I say? 1.912, okay. Okay. Start by creating a histogram of the amount spent. Then mark the following statement as true or false. So it's just asking if we created a histogram.
Um,
I actually forgot how. I think you just gotta graphs. Where's that at? Insert graph or table. Oh, here it is.
oh my goodness.
You guys know how to do that then?
I don't. I'm looking at it now.
You just go to, I believe you just go to the insert tab. Then you select all the data. And then there's little graphs in on the tab. I think it's the first graph on there. And then it just does it for you.
Under insert, I select everything and then click on which one?
I think it's the first bar graph or bar chart. Will give you the histogram.
If you just insert chart and you can add a histogram that.
Okay. Yeah, oh, there it is. I found the histogram one.
Where's it at?
It's on mine. It's, you see that? It's about middle of the tab, and there's all these different chart drop down.
Right.
On mine, it's the very middle one. It's, let's see, second one down, second one over. You see that?
Mine are just in a line. I see one that says column, line,
A
pie,
chart.
bar, area, scatter.
One of the drop downs says histogram on mine. I'm on 2016 Office. I don't know if that makes a difference.
I don't know, maybe.
Can you guys hear me?
Yeah.
Yeah.
If you just click on recommended charts next to the charts that it gives you,
Uh-huh.
and then click all charts, the tab for all charts, you can select histogram right there. You don't have to guess which one it is.
There you go.
You said to select the drop down?
He's saying if you see recommended,
Yeah, I don't see that.
what year is your Microsoft Office?
I do not know.
No. Yeah, that might make a difference. I'm not sure.
Yeah, that's what I'm wondering too.
Yeah, which one it is? Maybe yours doesn't even have a histogram option. I'm not sure.
That's what I'm thinking.
Yeah.
So what does your guys' histogram show?
Mine looks skewed left, or skewed right, I guess it would be.
So the majority of the data is on the left?
Yeah. Or actually, yeah. I could show you real quick. Let's see. Share my screen. I think. There it is. That's what mine looks like.
Yep.
Awesome.
Yep. All right. Moving on. Okay. So I'll read this little information thing. Jessica Meir and her research team measured the body temperatures of a sample of dividing elephant seals. A thermistor was placed at a specific location on each seal to measure its body temperature. The body temperature of seals tends to decrease as they dive. The researchers estimated the typical body temperature of each seal at the time they initiate a dive and called this the representative temperature of a seal. Thermistors were placed in the hepatic sinus of 4 of the seals named Bodil, Roberta, Larry, and Per. The seal's body temperature at the start of the dive was calculated to be, and it gives us those. Complete the following table and use your work to answer the next 4 questions. So let's figure out the mean. Okay, I've got a mean of, that's not right.
I got a mean of 38.075.
That's what I have too.
All right, I'll take your guys' word for it because I added wrong. Anyways. What was it? 38.07?
5.
Yeah, 0.075.
38.075. Okay. And then okay, so the first column we just take the mean and subtract the temperature there, and we get the deviation from the mean. So that's pretty simple. And then square deviation.
So we need to figure out the
We need to figure out what?
standard deviation.
Do we? What's the x over the line with the line over it mean? Is that
The X bar, the sample mean.
oh, okay? So yeah, I don't think we need to figure out the standard deviation in this one.
What does deviation from the mean mean?
That's just the individual deviation, so it would be 38.075 minus 37.91 for the first one.
Yeah, so because the first two are below the mean, those are going to be negative numbers, and because the next two are above the mean, they're going to be positive.
Yeah, exactly.
I was reading that completely wrong.
Yeah. So the first one's going to be. Well, .91. So the first one I have negative 0.165.
Yep.
Negative 0.165. Okay. B.
Wait, 6.5?
So the next one, I did it on my phone calculator. Squared.
So squared is all we're doing is taking that answer that we got and then just multiplying by itself to square it up.
So what if I'm reading this right? You just take the deviation, which is what was it, 38.075 minus 30 or 37.25 minus 38.075,
Right.
and then square it.
Okay. I got a 0.681 if you round it.
Yep. That's what I got.
What'd you get? Yeah.
0.681.
Yeah, 0.681. Because we're just following the what's it called? The equation
Yeah.
that it shows us.
I thought I was too, but I did it wrong.
Yeah, so with Roberta's, hers was 37.25. And so if you take that away from 38.075, that's still a negative 0.825, and then you're just going to multiply that by itself. So because it's two negative, it's going to become a positive.
Yep. And it's 0.681.
Yep.
I scored it wrong in Excel.
Number 13, what quantity is equal to the sum of the numbers in the squared deviations column? Quantity.
Golly. I don't remember any of this stuff.
I don't either.
Well, that's the thing too, is that the instructor in the last video especially emphasized that this unit is focused on these last few weeks that we've done. The next unit will be on the next couple weeks, and next unit, that kind of thing. It keeps going on, and so each quiz is going to be on each of those segments. But then the final is everything. He says you can't forget anything. I told him, great, no pressure.
Gosh.
So yeah, it gets tougher as it goes. I would think it's just the standard deviation, because all we're doing, it says take the sum of what we found in the square deviations. Well, no, it's a square though. So it's sum.
I don't know what the variance is.
So the mean was 38.075.
Yeah.
Right, and then this points.
It'll be the variance.
The what variance means?
Yeah, I googled it. Under probability theory, the statistics variance is the expectation of the square deviation of a random variable from its mean. Pardon me for a second, I'm relocating.
All right, so you guys on 15?
What'd you guys get for 14? Oh, that's just standard deviation.
Sorry, I was out of it for a little bit. What did we decide on 13?
13
Variance.
variance.
The variance? Okay. And then what is the standard deviation of these temperatures? Okay, so that's pretty easy. Let me check.
Yeah, run it. Make sure I did it right.
Mhm.
0.715.
Yep.
Okay, let me see if I get the same thing. Yep, that's what I got too, so we're good. 0.715. Okay. Under certain conditions, the standard deviation can be negative. I believe that's false.
That's what I have.
Yeah, I don't
Unless
see
they
how it can be negative.
make the data negative, could it be negative? No, I don't think it can be, right?
Yeah, no, it can't be. I think the worst it can be is zero deviation.
Yeah. Yep, okay. The same study, the researchers placed thermistors in the 3 seals. And in the spinal cord, they placed thermistors in 6 other seals. Okay, the largest artery in the body, finally, they placed thermistors in 4 other seals, blah, blah, blah. So they placed thermistors in many parts of the body. The results from this study are summarized in the data below. And they got the different types: body, sample size, the mean, and the standard deviation. Perfect. Which location resulted in the most consistent temperature measurements from one seal to another? That would be the one with the least standard deviation, right? So that'd be the extradural.
Yeah, that's what I would put.
Okay. Oh, we're back to this box plot. So the boxes, remember the first time we did that? They actually mean something. I still don't understand. We never got the quartile thing down, but I still don't understand it.
Yeah, the third quartile, that one was the one that always got us.
Yeah, we couldn't figure it out.
I'm trying to recall because he went over that in one of the videos I watched earlier today while studying.
Come on, Kelly, we need you here.
Yeah, no kidding, right? No pressure.
Yeah. What is the third quartile? So we're 2 to 12, right?
No, but that one wasn't right.
So would the third quartile be 8?
When he used the quartile situation, it was on the applet though. It wasn't on a box plot.
I believe, I think I looked at a little bit of it. I thought that the box plot showed from quartile 1 to quartile 3, and then the middle line there showed the Q2 or the middle. I'm not sure though.
We'll go with 8. That sounds, I mean,
Yeah. Let's see if we
I
got
think
that.
we ended up getting it right, but I don't.
We got all of it right except the Q3, the quartile 3.
So you guys are going with 8, you said?
Yeah. What percentage of the data lies between 4 hours and 8 hours? Note, list the number as a percent and not as a decimal, and don't include the percent sign. Example, 66 is 66, not 0.66, okay?
So are we saying 75% then?
Can't recall. It's either that or it had to do with the 68, 95, 99.7 rule.
Well, that was 66.7, wasn't it?
Yeah, 67 point something. I don't remember. 2/3.
Yeah.
Yeah, I don't recall how to read the box plot itself, though. If that little O with the 6 above it means anything, or...
Yeah, I can't remember. Here's, hopefully this will tell us something in the reading. Quartiles/percentiles, 5-number summaries, and box plots are tools that help us understand data. The 5-number summary of a data set that contains the minimum value, the first quartile, the median, the third quartile, and the maximum value. A box plot is a geographical representation of the 5-number summary. So I think that's what it was then. I think it shows from Q1 to Q3, the box part of it. But I'm not 100. I'm not sure on that one, to be honest. Let's see if it says anything else. Here we go. The number of hours students spent studying for an exam were recorded. The data are represented by the box plot below. Use this box plot to answer 18 to 19. This doesn't give us the answers.
Oh, and it's called a box and whisker plot, really?
Yeah. So I just searched box plot in the reading, but it doesn't give me a lot of information.
I'm trying to load a Google page and it is not working.
Let's see if I can find anything helpful. Okay.
Okay, so far, what I'm getting from it, so the 2 to 12 marking is where the data range is.
Mm-hmm.
So the range itself is only 10 years. So the third quartile should be 8. Or, I'm sorry. Yeah, third quartile should be 8.
Yeah, that's what I'm getting to, is the box shows the
Right.
lower quartile to the upper quartile. So it goes, so that should be 50% of the data, not 75 actually, right?
Right. Yeah, that's what I'm looking at too.
Yeah. So that shows 50% of the data.
So the line that bold line that goes down the middle of the box, slightly to the left, that's your mean or median.
Yeah.
That's your median. So it's basically our population versus our statistics or whatever, like it was a previous question.
I don't know. Yeah, I would say number 18 though is 50.
Yeah.
So that's good. And then yeah, 17 is 8, 18 is 50. That's what I would go with for sure. So I think we're correct on that, hopefully.
Okay, it says an observation Observation from a normally distributed population is considered unusual if it is more than 2 standard deviations away from the mean. There are several contaminants that can harm a city's water supply. Nitrate concentrations above 10 parts per million are considered a health risk for infants less than 6 months of age. The city of Rexburg reports that nitrate concentrations in the city drinking water supply is between 1.59 and 2.52, and the values outside of this range are unusual. We'll assume that
It's the mean
the mean is 2. What is it? O after it.
standard deviation.
Mm-hmm.
So the mean is 2 standard deviations?
Mean minus 2 standard deviations equal 1.59.
Right.
And mean plus 2 standard deviations equals 2.52.
Okay. So that's the equation. It's reasonable to assume the measured nitrate concentration is normally distributed.
Okay. Estimate the mean of the measured nitrate concentration of Rexford's drinking water. Wouldn't it be directly in between those two numbers?
I would think so.
Directly in between them?
Yeah.
Or
So I would put 2.055.
okay. So you take the average of them.
Yeah.
Okay.
Yeah, I think that's right. Okay, estimate the standard deviation of the measured nitrate concentration. Okay.
Oh, did we do that wrong? Is
So if we just
19.2 and 20 is 2.055?
No, I got 19 as 2.055.
yeah, 2 point, yep.
But to get that, we took the standard deviation.
Now to get that, we just took the mean of 1.59 and 2.52.
But I thought the
And-
mean was 2.
What's that?
Oh, okay. I'm looking at I forgot this is the equation. Okay.
And then now we just solve the equation for the standard deviation, which shouldn't be too hard. So I'll go. So I got 0.233.
How'd you come up with that?
So I just took the equation mean plus 2 standard deviation equals 2.52.
Mm-hmm.
And
Oh,
I stuck the mean in there and just solved for standard deviation.
gotcha.
That makes sense?
Yep, totally. I
So
wasn't looking at it linear wise.
Yeah, so if you want to do that equation and see if you got the same thing, that would be good.
What did you get?
0.233.
Yep. If you round it like that, yeah, I got it.
Yeah,
I must be doing it wrong.
which we could be.
I'm sure I am if you guys got the same answer.
We just took the 2.055
Right?
and subtracted it from 2.52
Right.
and divided it by 2.
Correct.
Oh, that's what I'm doing wrong. I'm missing that step. Hey, guess what? I got 0.233.
0.233, yeah, that's what we got. Okay, so now we use the applet for this one.
For 21?
Mm-hmm.
I believe so.
Yeah, that's what it looks like.
No, we shouldn't need to. We should just be able to subtract our standard deviation from the mean. Because we know that 68%. Oh, no. What's that rule? The
68% is going to be one standard deviation away. So yeah, you're right. So we have the standard deviation, which is 2.055, correct? Oh, no.
No,
Point
the
233 is our standard deviation.
right.
And then
yes, we would subtract that from the lower one.
Yeah. So we just take the 2.055 and subtract it by 0.2.
No. You take 1.59 minus your 0.233 equals 1.357 on your low end. And you take 0.233.
I thought the 68% are going to fall within one standard deviation, right?
They are. You're taking one standard deviation below 1.59 and one standard deviation above 2.52.
No, our mean is 2.055 though. So the one standard deviation away from 2.055 is 68%. 1.59 is two standard deviations away from the mean. So if you subtract 0.233 from that, you're three standard deviations away from the mean. Does that make sense?
So you're saying it's 1.823 and 2.2.
1.823 and 2.288 is what I would get.
Yeah, that's still the fourth one. Yeah, I was looking at it wrong.
2.288. Yep, that's what I would do.
Yeah, and that's the only one I'm really getting, working it either way that you guys have discussed to really make it work on both ends. Is the 1.823 and the 2.288.
Okay. Sounds good to me.
All right, I guess I'll finally read the next one. The admissions committees for most Masters of Business Administration programs require the graduate management admission test as part of the application for new students. It has been shown that the scores on the GMAT are normally distributed with a mean of 542.3 and a standard deviation of 120.54. The minimum GMAT score required for admission to the MACC program is in the School of Accountancy. Do we really know all this information? At BYU is 500, but it is rare for students to score less than 600 to be admitted.
Okay. What is the probability that a random selected student will score above 542.3? So So we just did something like this. Let's see. GMAT 5.2. That just be 50%. If the mean is 542.3, 0.5.
So what would be considered the data then? The 600 or the 500? 600, right?
No, the mean is 542.3.
That's the mean, but we got to work off of the mean, the standard deviation, and then work off of the 600.
Well, that's the thing. It would be, our z-score would be 0. So I would just say 50, it's a 50% chance that someone scores above that. So I would put 0.5 as the answer.
I said, are they that tricky?
I don't think it's that tricky.
I know, but are they that tricky? Is there?
Oh, yeah. I mean, if there's no z-score, if you plug that into the applet, it'll just give you a line right down the middle, and then it'll give you 50% as the answer. Because the z-score is 0, since the mean is, they're just asking how many people will score above the mean, which is 50%, because the mean is 542.3.
Yeah, I see that. But how do we put the answer in there? Do we put it in as a whole number, 50, or do we put it in as 0.5? It doesn't give specifics.
No, it doesn't. I would do 0.5 since that's usually how they ask for it. Selected student score below 600.
So now we just add the.
Yeah, now we're going to use the 600. So find the z-score for that. 42.3 divided by 120.
What's the z-score again? That's the 600.
So you're going to do 600 minus the mean, which is 542.3. And then you divide that by the standard deviation,
right?
Which is 120.54. And then you put that answer into the applet, which I've got 0.479.
Yeah, that's what I got when I round it.
0.479 into the applet. And so the answer will, you select everything above the right hand line. I've got 0.316.
Is that what we want to put, or do we want to put 32? I don't know.
Oh, yeah. They really don't specify at all, huh?
I think 0.316 is good for now. I don't know. We can change it, I guess, as we go.
Yeah. 0.316.
The score above. And that would be the same answer. 24. Oh, no, 600 and above. That would be the remaining. That would be the center and the right. So 60.684.
Oh.
Oh, yeah, 23 is wrong.
Yeah, 24 is 0.316. I read that wrong.
Good catch.
24 is 0.316.
Yeah, and then 23 would be select the middle and the lower, which would be 0.684.
Oh, yeah, you're right. I was thinking just the mean, not the 600 value.
Yeah. So sorry, I was reading that one, number 23, wrong. So I got 24 is 0.316. 25, find the GMAT score that corresponds to the 10th percentile.
I don't want to do that.
I know. Gosh, this one's complicated, I remember.
Oh.
I gotta go grab a power source real quick. I'll be right back, sorry.
Right. What's the standard deviation?
120.54.
And what's the mean? One.
Mean is 542.3.
I am getting 387.77.
How did you come up with that?
It's a formula I kept from the videos that I've watched all day today.
Awesome. Okay,
So
formula.
what we have to do is we have to go into the normal probability chart, and in area we have to type 0.1 for 10%.
Okay.
That gives us a z-score of -1 point, because we have to find that 10 percentile, which is the left side. So we have to find the z-score, which is -1.282.
Do you have it on your screen?
What's that?
The equation that you found?
Uh-huh.
Share your screen.
I don't know if I can. Let's see.
It's on the left-hand side, the green button.
Share that.
Did you find it in this week's reading?
I literally watched every single video that he posted today throughout the course of the semester so far.
Oh, okay.
So I don't remember what week this is from. It's probably lesson like 6 or something, 6 or 5.
I do remember the equation that they gave, but I can't remember where it is.
So what I wrote down was the z-scores here. So I had to enter in the 10% under area at the very top of the applet. And because we want the 10th percentile, we want what's below that. So it came to a -1.282.
Okay.
The standard deviation is the 120.54. And then my equation here is just multiplying those together.
Huh.
Okay.
Cool.
And then if I have the mean, which is the 154.3, I then have to add those together. And then this is what the 10 percentile will score. 387.768.
What was that number?
The answer I got was 387.768. I don't know how far out they want us to go with the score, though.
This is the nearest 10th percentile, or the nearest percentile.
So then it should be a 387.8, I guess.
It says round to the nearest whole number.
Oh, the nearest whole number, okay.
The 388.
Yeah, so 388 then, yeah.
Okay. I'm sure you're right. I would just go find it, but I don't want to. So.
No problem.
Okay, find the GMAT score that. Okay, now we have to do the same thing for the 90th percentile. Wouldn't 10 and 90 be on the same? No, I guess it would be the same.
Yeah, because you had a negative number.
Wouldn't 90 percentile be 1.282? Or no? For the z-score? Would just be the opposite of the 10. I
And no,
thought.
it'll be the same. Yeah, it'll be positive 1.82. So basically, you're adding to the 542.3.
Yeah.
How are you guys getting the z-score from the percentile?
On the applet, it'll show you.
So when it's asking you to find the percentile, then you have to type that in. Like that was the third quartile or whatever that he put in, that Brother Bennett put in as well. So if you're looking for any kind of percentage to find the z-score, you got to put it in the area because that is the percentage, and then it'll give you the z-score automatically.
So your z-score is 1.282.
Right, but the difference is that this is positive now, so when we multiply it to the standard deviation, it's going to come out with a positive 154 instead of a negative 154, which is going to add to the 542 instead of subtracting from it. So
Yeah, that makes sense.
yeah, so instead of the 388 that we got, now I have a 697 if I round it to the whole number.
697. That makes perfect sense to me.
So you got, I'm sorry, so you took the z-score and you times it by the standard deviation?
Correct. And then that number, whatever that equals to, you add it to the mean.
To the mean, yeah.
Right. So if it happens to be negative, it'll automatically subtract it, but if it's positive, it'll increase it.
Correct, yeah.
And we had our mean as
542.3.
Right. Yeah, we're allowed to have notes when we take the quiz, and so that's definitely one of the equations I'm holding on to.
Yeah, for sure.
we got 697.
Yep.
Okay.
Okay, find the first quartile of the distribution of GMAT scores. So wouldn't that be the 20? Wouldn't that be doing the exact same thing but 25%?
Exactly, up in the area, yeah. And because it's the first quartile, I got a negative 0.674.
Yep.
And because I already have the formula in, that's all I have to change is that one part of the equation, and I got a 461 score.
461. So yeah, so it would be, you would take the negative 0.674, multiply it by the 120. What was the number? 120.
0.54.
20.54 times. So,
What was the median?
The mean is the 542.3.
so yeah, you got 461. Yep. So that's perfect. That's what I got.
You guys got the 461 as well?
Yep.
So find the third quartile. So the exact same thing again, except we just got to take the negative symbol out. And I have a 624.
Yep. 61.
You're on the clutch, Kelly.
Only because I got the equations, man. God bless Excel.
Consider a simple random sample of n equals 15 students taking a GMAT. What is the mean distribution of sample mean scores for all such samples? Okay, this is where I'll come in because I just did this actually, not too. I think I did it on Saturday. I was doing a bunch of these. So let me just remember. So since the distribution is normal, the mean is going to remain the same of the 15. So the mean of the 15 students is going to be 542.3. And then I think it just remains the same, 542.3.
How'd you come up with the 5.42 or whatever?
Well, so since the distribution is normal,
Uh-huh.
taking in a random sample of any number, the rule is that the mean remains the same of the mean distribution, or the mean of the distribution of sample. Mean scores remains the same as the parent sample, which is 542.3.
Right.
Oh,
And because they don't tell us what those student scores are, there's nothing to recalculate either.
Yeah, exactly.
Yeah, so because they don't list out those 15 scores, we can't find a new mean within those 15. So we might find all 15 students that happen to score that, whatever, that 388 score, and then that would be the new mean. But because we don't know their scores, there's nothing else to calculate, so it has to be the 542.3.
Yeah. And then this part is going to be the part that's different. Standard deviation is going to be different with this one. So if I remember correctly, what you do with this is you take the standard deviation, which is 120.54, and then you divide that by the square root of 15. Why you do it that way, I'm not sure, but that's how you get the answer.
Oh, this is one of those equations. Okay. This.
So I got 31.123.
Yep, that's what I got. So Alex, do you know what that equation is?
no, I don't.
Okay, so just go ahead. Are you in Excel now?
Yep.
Yeah, like I said, I watched his videos. They were super helpful. So you're going to hit the equal sign.
Okay.
And the standard deviation is the 120.54. You're going to put divided by, and you're going to type in SQRT for square root.
Okay.
Left parenthesis, because the sample size is 15, you're going to put that in parentheses and just hit enter. And that's how you get the 31.123.
Sweet.
You good?
Yep.
Cool.
I need to watch those videos and get those equations.
Yeah, well, he also said that it wasn't going to be available except for like Tuesday and Wednesday this week to take the exam, but I went into it now to see if there's any special directions in it before you start, and it says you can go ahead and start now.
Oh, really?
Yeah, so I'm tempted to do it tonight just to knock it out, just because I hate knowing that an exam's coming when I have the ability to take it.
Yeah, exactly.
I mean, if it was barred and it was timed and you couldn't open it till tomorrow, then I wouldn't sweat it, but because it's available, I don't like waiting.
Yeah, I'm with you there. Last one. What is the probability that the sample mean GMAT score for an SRS of n equals 15 students will be greater than 600? Okay, so this one, I remember doing these. The only difference is we're going to use the same mean, but we're going to use the standard deviation of 31.123 instead to figure out the z-score. So what you would do is 600 minus 542.3 equals 57.7 divided by 31.1123. And then, so the z-score is 1.854.
Is what I got, yeah.
And then you plug that into the applet. 54. And then you select everything to the right, and it's 0.032. You guys follow?
Yes, sir.
All right. Someone want to submit it, or should I?
Last time I said I would, so I'll go ahead and do that first. And then last one, 0.32. Yep, okay. And go to submit.
We only get one attempt.
Oh, really?
Oh.
Maybe not. Maybe not.
No, I think
Maybe
we
I'm-
get to it.
Yeah, no, you get 2.
Yeah.
All right, I'm seeing our percentage first. All right, well, good thing is we got a 90. I got a 95.
Cool.
So we missed 1.
Oh, that's not bad at all.
No, not at all. Because each one's worth a point. I'm trying to find it. 13. It's not variance, which is weird because I read the definition.
We got partial credit on
On number 2.
number 2.
Yep.
We got partial credit.
Yes, we got 2/3 of a point. So I think we need to take away age and years.
Yep.
Okay,
So
let me get up.
Number 2.
So I'm going to take away age and years. Got that. And then, what was it, number 13, right?
Yeah, number 13. It's not variance. Those are the only 2 that we missed, partially and a whole one.
Okay, so what quantity is equal to the sum of the numbers in the squared deviations column?
It's not going to be the mean. It's not the standard deviation because it's a squared deviation. So it's got to be none of these is correct.
You want me to try that one?
I think so.
None of these is correct. All right, well, we'll get another shot at it if it's wrong.
Right.
I'll just... Okay. Quiz. Got 100.
Excellent.
Yep. So you guys want me to walk you through it?
Yeah, let me reopen it. So number 2 is just randomly selected.
Yep.
Toothpaste. Number 3 was the 100 is parameter, 112 is statistic.
Correct.
And these ones I don't remember. Stratified, right?
Stratified, yep. Are you with us, Alex?
Yep, I'm there.
All right, perfect. Number
What
5.
was 5 again?
5 is a cluster sample.
Cluster. Okay.
6 is a
Stratified again.
simple
Oh, simple. That's
simple
right.
random sample. 7 is a stratified random sample. 8,
Mm-hmm.
you guys with me?
Yep.
4.771.
Okay.
Number 9, 1.912.
Okay.
Number 10, true.
Yep.
Okay.
Number 11, negative 0.165.
Negative 0.165.
Yep.
Okay.
Number 12, 0.681.
681. Okay.
Number 13, none of these is correct.
Okay.
Number 14, 0.715.
Okay.
Number 15 is false. Number 16 is extradural.
Okay.
Number 17 is 8.
Oh, one thing about that too, on the box plot. So I was reading more and researching more about it. So the 2 and the 12 is your range. That first section between that 2 and where the left side of the box is at 4, that's your first quartile. The second quartile is the 4 to 6, where the 2 bars meet. That thick bar in the middle and that left bar, and then the right bar of the box and the thick bar is your third quartile, and then the that remaining long stretch is your fourth quartile. So found that interesting. That helps me look at the box, and I can identify each section now.
Yeah, now we actually know what the box plot means, so that's good.
Exactly. 5 weeks into class.
Yeah.
All right, what do you got for 18 then?
18 is 50. 19 is 2.055.
Okay.
Number 20 is 0.233.
Okay.
21 is 1.823 and 2.288.
Okay.
22 is 0.5.
Okay.
23 is 0.684.
Okay.
24 is 0.316.
0.316.
Yeah.
Excellent. Okay.
Number 25 is 388.
Okay.
Hold on just a second. 25 is what's that?
388. 388.
188. Okay.
26 is 697.
Okay.
27 is 461.
Okay.
28 is 624.
Okay.
29 is 542.3.
Okay.
30 is 31.123.
Okay.
And then 31 is 0.032.
0.032. Got it. Cool. Right on.
100.
You guys got it?
Yep.
Yep. Hey, you know what though? Even on the exam, I'll take a 95. Shoot.
Oh yeah, if we get 95 on the exam, I'll be happy.
No kidding. So awesome.
All right, guys. Good luck on the test.
Okay.
Yeah. Thanks. You guys too, man.
So do you guys still want to meet on Wednesday then?
Yes, because we still have to go over lesson 9. The good thing is we don't even have to post this. We just have to, like this video tonight, we don't even have to post it. We just got to do it together. That's all. And then, yeah. So and then there's no homework either because we have the exam. But on Wednesday night we do have lesson 9 due.
Yeah.
So and that will not be on the quiz.
So I guess I guess I didn't need to broadcast, but whatever.
So yeah, I think I'll just plan on doing the exam tonight.